Welcome all of you. Unit number 5. Inverter. What is inverter? It is just opposite to the rectifier. Rectifier means AC to DC. Mobile phone adapter. AC to DC to charge the mobile phone. Inverter means DC to AC. DC to AC conversion. Why I need DC to AC conversion? It is simple to say UPS, uninterrupt power supply in your home. Okay, inverter or UPS power supply is there. What is the purpose of UPS? Whenever power is failed, whenever is power is not available in your home, it is a UPS available. From the UPS, it will going to give the power supply. How it is giving the power supply? When power is available, at the time the battery it will going to charge the energy. Battery it will going to charge the energy. When power is failed, the battery it will going to discharge through the inverter, DC to AC converted. Then AC is the output of the inverter. It will going to give the appliances. Your appliances operate on the AC power supply. So like that, the inverter is operated. That's all. Then when you have go for the content. So here is a single phase inverter, three phase inverter. Like about that how the rectifier is classified single phase and three phase. Here also single phase inverter and three phase inverter is there. In that unit number 5 you will going to study about that single phase inverter. Unit number 6 you will going to study about the three phase inverter. Unit number 5 single phase inverter. So when single phase inverter also classified into the two types, one is a voltage source inverter, second one is a current source inverter. Voltage source inverter, second one is a current source inverter. Then third one of the topic is given. What is the topic? PWM technique. So single pulse or multiple pulse or the sinusoidal pulse modulation. What is the purpose of that PWM? It's nothing but a controlling technique. So what is the meaning of controlling technique? Or you can call it as a previously you can call it as a triggering circuit, or you can call it about the firing circuits, or it is a delay angle. It is angle. It will go to angle through which the thyristor is a turn on. Okay, angle through which that one the thyristor is conducted. Angle through which the semiconductor device is on. That is a delay angle. Okay, like that one. Here is a single pulse method you can use, or multiple pulse method you can use, or sinusoidal pulse with modulation you can use. Any type of the method you can use to you can give the pulses to that the switches. Pulses you can give to the switch. That's all. So here is a content. What about that one? Inverter is a classified into that one single phase, three phase. In that unit you will going to see about the single phase inverter. In next unit you will going to see about the three phase inverter. Okay, in single phase inverter is it's further classified voltage source inverter, current source inverter. Inverter means what? DC to AC conversion. DC to AC. How? Okay, DC is stored into the battery. It will going to converted into the AC. Okay, so otherwise it is you can use a DC generator also. You can DC generator, it will going to produce the DC electrical output is produced. You can use the inverter to convert the power supply. Okay, convert it into the AC. So in olden days, okay, some you have seen possible to see about that bank. Okay, some generator they are operated generator set they will going to generator they will going to operate the okay on the generator engine. So once the engine is started, it will going to give the power supply. So like it is the conversions they are using for that one. So DC to AC. So let's say we're going to move to the topic of that voltage source inverter topic. What about that one? DC is I will going to apply the here DC and the converter to AC is here. So if I have see how many number of the controlling switches used, there are 4 controlling switches are used. Okay, as usual. Okay, I said about that rectifier operations. Similarly, the symbol of the X or the multiplication symbol. So here also same multiplication symbol. Okay, mode 1 operation. This cross is operated. So T1 and it is denoted T2. So T1 and T2 is operated. Mode 2 condition. These two is operated. Okay, these two is operated. So like about that ones. So when you will going to give the power supply, so it is a T1 and T2 is operated to, you can close the power supply. So like it is closed. Okay, when next one, okay, then second half is what about that one? Okay, it is the same, it is a flow from here to T3 and T3 to load to close. So like it is coming on the two ones. So previously this forward direction plus with respect to minus, then next mode conditions, here is a plus with respect to minus, opposite to flow. That's why it is opposite. So this is a plus and then this is a opposite. Okay, so T1 T2 and T3 T4 like the one cycle. Okay, like it is a developed one cycles. So this is a AC. So AC means pulsating type of the AC, pulsating type of the AC. Okay, and one next one, what type of the load is used? Are used R load? If I have used the R load means, okay, this is a waveform. This waveform is a output voltage waveform and output current waveform, both also same. Both also same. Output voltage and output current is a waveform. So this is a one cycle. The cycle is repeated. Okay, first of okay, off cycle. Okay, T1 and T2 is triggered. Okay, these two is not triggered. So due to the trigger, the current is a flow like that once. The next off cycle, T3 and T4 is a trigger. So due to the trigger, from here to the T3 load and then close the circuits. So R load, so output voltage and output current both also same. Okay. So here at any point output voltage is same as an input voltage. So if it is a source utilization factor will be 100%. Output voltage is equal to input voltage. So input voltage is a 200 voltage, then output also 200 voltage. Input is a 200 DC, output is a 200 AC. So source utilization is a 100%. So here is a input is a DC supply load. Okay, so DC supply. Okay, load or output voltage is a 2 times. Our output power is a 4 times in the full bridge inverter compared to the half bridge inverters. Then what is the difference between they are given as a half bridge and a full bridge? So full bridge means it's a 4 times the power compared with the half bridge. Okay, output voltage is a it is a, what about that one? Output voltage is a 2 times compare with that half bridge. Output voltage is 2 times. Okay, power, when you have compare with the power, it's a 4 times. The next one, when you go for the RL load. So here is a okay R load, okay, output voltage and output current I have shown. Then RL load, when you have used the RL load, output voltage is this is square wave, output current is about this is a output current. It's a triangular type of that current is rising. So rise, decrease. So on mode number 1 it is a increasing, okay, increasing. Mode number 2 decreasing. So like it is that once. So this is a output current when you are using the RL load, RL inductive loads. Well, that's all. When you have go for that one, next one is the current source inverters. Current source inverter also same mode 1, mode 1, mode 2. Okay, then what is the difference? Here is a point. I will go to okay, I mean showing that one. This is a point you will going to connect to one inductance. So when you are going to connect to one inductance is over here. So what will happen? It is act as the current source inverter. Okay, current source inverter. Then what about the waveform? So waveform means so what about that one in that voltage source inverter output voltage? This is output voltage. Output current, this is output current. Output voltage, output current. So this is just, it is a reverse. So this is output current and this is output voltage, that is called the current source inverter. So just you are going to look at that one. So this is about the current source inverters. So diagram you have see that once the same type of circuit diagrams. Here is a inductance is connected. Inductance is connected series with the source. It is called the current source. Inductance is connected with the series with the source is called the current source. And then you have see that once. Okay, here is the output current. Output current is a square. Previously output voltage is square. Excuse me. Here is a triangular. That triangular, what about that one? Output voltage is a triangular. That's all. This is a difference between the current source inverter and the voltage source inverters. Okay, so the waveform wise is a differentiation. And then few more depth about why do I want to go for the current source inverters. So if the load is a capacitance load, if the load is a capacitance load, the current source inverter is suitable. So easy to remember. So C So current source for capacitance. Voltage source inverter is suitable for that inductive load. Voltage source inverter is is inductive load. Okay, so what about the square waveform? So square waveform is produced for that output current, and triangular waveform is produced on that output voltage. So this is about that current source inverters. The next one is a pulse with modulations. Pulse with modulations. So it is generally it will going to classified basic about that pulse with modulation. You will going to variable the output of that ones. You will going to generally it will going to classify. First one is a external control of AC output voltage. So external control of the output voltage or AC output voltage. So external control of AC output voltage means, so first one inverter. What is inverter? DC to AC. After that AC, I will going to use one AC voltage regulator. AC voltage regulator. So the AC voltage regulator fixed AC to variable AC. So it is a output of the variable of the AC I will going to get. That is called the external control of AC output voltage. The next one, external control of the DC input voltage means what? My inverter is fixed, DC to AC, my inverter is fixed. The input of the inverter is I am using from using from the chopper. One more converter, that is called a chopper. So chopper followed by inverter. So chopper is DC to DC. So variable DC is you will going to give to the input of the inverter. The output also variable AC. That is called external control of the DC input, external control of the AC output. So like it is generally it is classified. And one more is the simplest method is called internal control of the inverter. That is called pulse width modulation technique. So this technique it is used to control the output voltage. Control the output voltage you will going to control. So PWM. So pulse width of the output pulses gets modulated. Width of the output pulses get modulated, while magnitude amplitude as constants. So magnitude is a constant like we will going to do. So width of the output pulse can be controlled by varying the delay in firing angles. So advance in that commutation angles. Okay, by properly selecting the width of the pulse, one of the harmonics in output waveform can be eliminated. So you will going to select the proper, when you have go for the inverter means harmonics is it will going to place major roles. So you will going to properly selecting the width of the pulse. Width of the pulse is properly you can select it to. So you will going to eliminate the harmonics. What is harmonics? Unwanted disturbances. It will going to make it it is noise. It will going to malfunction. It will going to start to do on that once. Okay. The next one we will go to classifications. So single pulse with modulation, multiple pulse with modulation, and a sinusoidal pulse with modulation, trapezoidal pulse with modulation, triangular pulse with modulations. Like it is so many type of the modulations. So what is the difference between that all of the modulations? Okay, you will going to coming to learn about the here. So what is the purpose of this one pulse with modulation? To make that pulse. Okay, this pulse is you will going to apply into that your SES. So here is they are using one comparator and triggering pulse generator. One comparator and triggering pulse generator. So what is a comparator? The comparator it will going to compare the two signals. One is a carrier signal, another one is a reference signals. These two signal is comparisons, and it will going to give to that one trigger pulse generator. It will going to generate it. That's all. So compare the two signal and it will going to generate the pulse. Okay, so that's why based it will going to classify. One is a carrier wave, another one is a reference wave or triangular wave. Triangular is a wave. So another one is a reference wave. Carrier wave, reference wave. So what is a carrier wave? Triangular. It is a triangular fixed one. Here is a reference wave. What is that one? Sinusoidal. So here is a varying on that one. So you will going to apply the sinusoidal or a trapezoidal. So like you will going to varying. So now you can say carrier wave, reference wave. So carrier wave, reference wave, carrier wave, reference wave, carrier wave, reference wave. The first one, simple pulse with modulations. Okay, simple multiple pulse with modulation. So high frequency here I will going to apply. Here I will go to low frequency of that square wave. So triangular wave, square wave. So I will go to carrier is a triangular wave. 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 It's a constant. Then reference wave, what I will go to apply? I will go to apply the square wave. When I will go to apply the square wave, it will go to compare these two. Similarly, I will going to replace square into that sinusoidal. So sinusoidal pulse with modulations. So sinusoidal pulse with it's a square pulse with modulation or a multiple pulse with modulation you will going to achieve. So instead of that one, okay, sinusoidal is replaced into the trapezoidal. So trapezoidal pulse with modulations. The width of the output pulse varied in according with the magnitude of the trapezoidal wave. The next one is that trapezoidal is replaced into triangular. So the width of the output pulse is varies in according with the magnitude of reference triangular waveforms. So like I will show you the waveform how they will going to compare these two, okay, carrier and then reference. So this output of the waveform, it's finally it is produced. So like it you will going to come after comparison it is going to produce. So you can look it done that once. This is a carrier as well as a reference. So what about the carrier? It's a triangular waveform. Then reference is they are using the square waveform, is their used square waveform. So wherever the touching point, this is a touching point, this is a touching point, this is a touching point. So in the touching point only pulse is generated. So in the touching point only pulse is generated, like so the pulse is created. So then I will going to increase the more number of the triangular, means what will happen, more number of pulses I will going to create it. If I will going to reduce the one number, okay, number of the triangular is less, means what will happen, only I will going to use one triangular. So I will going to get it on the only two touching the points. So like about that pulse with the modulation is developed. So look this waveform. So what about number of the triangular is used? More number of triangular is used. So it is touch and compare with that one sinusoidal waveform. So like it will going to pulse is developed. That's all. So here is a voltage source inverter, current source inverter. Current source inverter is suitable for C capacity load. Voltage source inverter suitable for inductive load. Another one is a pulse with the modulations. Okay. Thank you.